So, the last online seminar was about the Eckhart pigment and metallic ink portfolio. How to choose the fitting pigment as mentioned below: cornflake, silver dollar, platinum dollar, and PVD. Here called vacuum metallized pigments for a dedicated printing result was answered. Additional, how to disperse a metallic pigments correctly was explained. Today's online seminar will be about the machine setup recommendations and the influence of substrates. We want to answer questions about what pumping system is the best for metallic pigments, what parameters have influence on the orientation of metallic pigments, what substrate leads to what metallic effect. We also want to talk about the influence of toners, what information is provided by the Eckhart TPI, and what influence has the printing form itself.
Our first topic is print form recommendation. The cylinders used in Gravure or Flexo application need to transfer the metallic ink. The better they do that, the more stable your production run goes without any decrease or change of effect. The cell shape can have a big influence on this, as the metallic pigments are shaped like little flakes. In worst case, they don't fit into the cells and are filtered out on the doctor blade, which will influence the effect and could lead to negative stripes in print direction. Or the pigment gets stuck in difficult cell shapes, which would lead to missing spots in the application. The flat cell geometry, here in the middle picture, supports the release of the pigment, whilst the deep cell geometry, the right-hand side on the pictures, could get blocked by pigments. You see this by this little schematic picture of the three pigments sticking down there. By using laser engraving, the cell shape can be better controlled to a positive working shape, whilst some standard engraved cell shapes are difficult in releasing effect pigments. Finally, any cell shape needs to be tested before any commercial print run if the release of the pigment is given to avoid troubles in production. For every printing ink from Eckhart, we provide guidelines, like the technical product information, or TPI in short. The TPI contains a lot of useful information, like the list you see here on the right side. Recommended dilution, for example, is very important, as not all binder systems tolerate pure alcohol or acetate dilution. What works best is provided there. Also, the roller configuration is mentioned with settings which work best on our in-house printing press. For example, we can see on the left side recommendation for full surface application, where coarser lineature and more ink will help providing the full effect, whilst the fine line needs finer lineature to print out the small details better.
The next topic is about the influence of different pumping systems. Different pumping systems can have an influence on the viscosity of metallic inks in the printing press. Eckhart has carried out a laboratory comparison of peristaltic pumps and membrane pumps. The picture shows the setup, which was as follows. A certain amount of the same ink was circulated in both pumps for the same amount of time. The ink in the left bucket was circulated with a membrane pump, while the ink in the right bucket was circulated with a peristaltic pump. The viscosity of both experimental setups was measured after a specific time intervals using a DIN 4 mm cup. We can see here the different foaming result of both pumping tests shown in the DIN 4 cup. The picture on the left shows a strong foaming of the ink stirred with a membrane pump. This can be seen from the many bubbles in the measuring cup and the bucket. The viscosity is difficult to measure because a lot of air was stirred into the ink. This leads to an increasing viscosity and a poor flow out of the cup. On the right picture, you can see the ink that was circulated with a peristaltic pump. Here, no foam was detected after the same time. The viscosity after stirring is still at the same level as before. Also, a look into the cup showed no air bubbles inside and a clean run out of the color from the cup. This setup expressed in numbers has shown the following results. Viscosities were determined at measurement intervals of 5 minutes. The diagram here shows the different viscosity curves. Shown here in dark blue is the almost constant viscosity of 25 seconds in the DIN 4 cup over the entire observation period of 50 minutes when using a peristaltic pump. In comparison, the increasing viscosity when using the membrane pump is shown in light blue. Here also the starting viscosity was 25 seconds in the DIN 4 cup. After 50 minutes, the measured viscosity was 52 seconds in the DIN 4 cup. Therefore, even over a short observation period, the strong influence of the pumping system used can be clearly seen.
Now, let's look into some parameters. How to compare metallic effects, what makes the metallic effect look metallic, and finally, how the solvent-based inks are in terms of pigment orientation. The European norm excludes the gloss level measurement for metallic effects. Why is that so? Because the measured values of metallic effects are not absolute. They change dramatically depending on substrate, applied ink volume, measuring angle, and many other factors. This means gloss measurement can only be comparative under the exact same conditions. When you take a perfect mirror in a perfect dark room and point a light source to it, in one angle you will be blinded by the perfect reflection of the light. In a different angle, you will not see the light source at all. From that angle, the mirror would appear black. In the middle example, we see what usually colors are: a matte surface. With a perfect matte surface, the light will be scattered in any direction. In our dark room with the light source, the matte surface will look identical from whatever direction you look at it. The standard metallic surface in our third example here, or metallic effect, is a mixture of these two extremes. It is partially reflecting and partially scattering at the same time. In the gloss angle, the surface appears bright. In the flop angle, less bright, but still partially reflecting. This effect is immediately recognized as a metallic surface. It's sometimes also called the flip-flop effect. How does the orientation of metallic pigments work in solvent-based systems? Usually, the pigments are sinking to the ground when applied, but still are in a between state and kind of chaotic dispersed in the wet ink film. Then, with the drying, the solvent evaporates and is shrinking the wet ink film to a dry and solid ink film. With the height reduction, the metallic pigments are forced onto the ground of the ink film and are matching the surface provided by the substrate. This improves the orientation of the metallic pigments and leads usually to a good metallic effect. The pigment binder ratio can be optimized either to provide the best looking effect by using low content of binder or improving the adhesion by adding more binder. This comes at the cost of reducing the metallic effect at the same time. The dried ink result is made visible here in the scanning electron microscope crosscut. You can see the rough substrate at the bottom of the picture. In this example, it was covered by a primer to improve the smoothness of the surface. The applied ink shows a perfect orientation of the metallic pigments on the surface. The binder system is sitting on top, protecting the pigments from being rubbed off. It is not always that perfectly sorted. Some pigment classes are swimming up in a binder system or are still in chaotic state dispersed within the binder system.
What also has a significant influence on the printing result of metallics is the substrate itself. The question is why to use coated paper when working with metallics. On base paper, shown here on the left, we can see the rough and absorbent surface, mostly with low whiteness. With single coated papers, shown here in the middle, the surface is already much smoother and shows a higher whiteness. With the double-coated papers, shown here on the right, the surface is very smooth and has a high degree of whiteness. So the coating increases whiteness, smoothness, gloss, and print quality. It increases the print quality, but why? Because coated, smooth substrates, in this case printed with black ink, allow a sharp and clean printout. It's the same when using metallics. The missing dots when printing on base paper become significantly less when the paper quality increases. An identical machine setting can therefore produce completely different printing results only by changing the paper quality. Since the substrate surface has an influence on the print, the use of primers can improve the printing result. Higher gloss values can be achieved. In this example, a print comparison of primered and non-primered substrate. Not only the chromatic colors have a different appearance, but also the metallic colors in particular. The use of the primer fills the imperfections in the substrate. This results in a smooth surface on which the pigments can optimally orient themselves. The absorbency of the paper also influences the print result. Absorbent substrates suck in the liquid components of the ink very strong and leave the metallic pigments with a small amount of binder on the surface. Additionally, the solvent in this example evaporates. This leads to low abrasion resistance since the pigments are not fully embedded in the binder in some cases. The overprintability is poor since the following ink cannot anchor itself on the bare pigment. The adhesion of the metallic ink to the substrate is low since the cross-linking binders are absorbed into the substrate. So Eckert made a comparison of different substrates. In the first example, pure solvent-based silver ink was printed with approximately 150 meters a minute. It was Ultrastar GP72100. It was printed with 70 lines a centimeter with a standard engraved cylinder on our Rotova 300 printing press. In the second example, the setup was the same, was just printed with a yellow tinted silver. To show in figures what influence the different substrates have, here an overview about the results. The gloss level decreases significantly from 455 gloss points on cast-coated paper to 18 gloss points on clay-coated paper. There is also a clear difference with colored metallics. While the gold effect is very strong with cast-coated paper and coated carton board, a low gold effect is seen with coated paper and clay-coated paper, as toner and binder are sucked into the substrate here. This effect is most pronounced on clay-coated paper. The different absorption behavior of its surface leads to an inhomogeneous printout. You can see this here on the right. Similar effects can also be seen with foil printing. In this example, the reverse printing of the Ultrastar GX2807, also with 70 lines a centimeter and 150 meters a minute printing speed, printed also on our Rotova 300. You can see the mirror image of a marble of the reverse viewed foils. The sharp, edged and clean printout on film decreases depending on the clarity of the substrate from PET to OPP and PE to PVC. Gloss measurements were also carried out here to illustrate the effect. For metallic surface printing on foil, a lineature of 100 lines a centimeters has proven successful. The lower application quantity ensures flat deposition of the pigments and a homogeneous glossy surface. Here also, the ink was printed with 150 meters a minute on our printing machine. The decreasing gloss level from PET to PE white and PE show the influence of the substrate surface.
Now, let's look how toner can have an influence on metallic effects. In this example, you clearly see that with higher amount of toner from left to right, the chroma or color strength is increased. This comes also at a cost of reduced metallic effect. This can have several reasons. The most obvious one is that by adding more colorant, the ink gets diluted, which reduces the overall amount of metallic pigments in this specific area. But also the quality of the color pigments have an effect. The more transparent the color pigments are, the better stays the metallic effect. Opaque pigments will dramatically reduce the final effect. Also, when very coarse color pigments are in the formulation, the metallic pigments are disturbed in their orientation, which again leads to lower effect by scattering more light. Smaller color pigments are better, as they do not disturb too much the metallic pigments in their orientation. So what did we learn in this episode? We have seen that the print form, Anilox or Gravure cylinder, is influencing the metallic effect. It makes sense to test several possibilities to find the best compromise for the design which is going to be printed. Second, also the right choice of pumping equipment can help preventing from a reduction of metallic effect. We further saw what creates a metallic effect in the watcher's eyes and how the drying of an ink helps to create the effect. Further, the choice of the substrate is crucial for influencing the final result. The smoother, the better the resulting effect. Blending components like toner needs to be tested to maintain as much metallic effect as possible. So, the next seminar in December will be about metallized board, how this compares with ink, and why ink is the better solution in terms of sustainability aspects and many others. Within the next days, you will receive a copy of this presentation. In there will be our contact details, as shown here, if you would like to know more about our topics from today. Thanks to you all for joining our web seminar and staying with us until the end.